Welcome to Foundations in Pre-Calculus Math 10 with Mr. Johns. Today we're going to start Chapter 3. Chapter 3 is about factors and products. And we start with numbers, and then we move on to polynomials. The first thing we're going to talk about is prime numbers. Now, prime numbers are special because they are only, divisible by the number 1 and the number itself. So a number like 2 is only divisible by 1, or the number 2. 3 is only divisible by 1 in itself. 4 is divisible by 2, so we won't include it, but 5 is divisible by only 1 in itself. 7 is prime. 9 is prime. You'll see there's no more even numbers because 2 would divide into them. But 11 works. 13 works. We can't do 15, but 17, and so on. Prime numbers continue infinitely, but they get few and far between as numbers increase. The next thing we'll talk about is prime factorization. And this is determining the product of prime factors that make up a number. An example of this would be like the number 18. Well, to get 18 as a product of primes, I would take 2 times 3 times 3 again, which is like 2 times 9 or 3 times 6. Either way, I get to 18. If you don't understand it yet, that's okay. We're going to go over it some more. So now let's look at our assignment. I'm going to do a few examples with you. There's a special way of factoring called a factor tree. And so what we do is we take a number like 144 and we keep dividing out prime factors. I always start with the smallest and work to bigger ones as I need to. So if the number is even, I'll keep dividing by 2. So 144 divided by 2 will give us 72. It's still even, so I'll divide by 2 again, giving myself 36. 36 is even, so I'll divide by 2 to give myself 18. Still even, so divide by 2 to get 9. And now I need a new prime factor. 3 works. 9 divided by 3 gives me 3. And I'm left with a prime number, and so I can stop. Then I'll carry these factors down to get my product of prime factors for the number 144, which is 2 times 2 times 2 times 2 times 3 times 3. And since we have repeated multiplication, I can write it as 2 to the power of 4, because there's 4, and 3 to the power of 2. Let's try another one. $252. 252 divided by 2 is equal to 126. Divide by 2 again, I get 63. Well, I can't divide by 2, but 3 works, leaving me with 21. Divide by 3 again, and I'm left with 7. Well, 7 is a prime factor, so I can't go any further. So I have 2 times 2 times 3 times 3 times 7. So the prime factorization of 252 is 2 times 2 times 3 times 3 times 7. You'll notice I use a dot for multiplication instead of an x because we'll be working with x's. I have 2 2's, so it's 2 squared times 3 squared times 7. Now you can try 1b and 3b. Moving on to the back of the sheet, we're going to look at a GCF, which is known as the greatest common factor between two numbers. So it's the number that's the biggest that divides evenly into both of them. So if I take the numbers 44 and 70 and I want to find the greatest common factor, or GCF, I'll see what all numbers divide into 44. 44 divided by 1 is 44. I'll divide it by 2 and I'll get 22. So 44 is a factor, 1's a factor, 2's a factor, 22 is a factor. I could also divide it by 4 and get 11. And I think that's it for factors. So the factors of 44 are 1, 2, 4, 20, I'll say 11, and 22. For 70, I'll get 70. You could divide by 10 to get 7. You could divide by 5 to get 14. And I could divide by 2 to get 35. So the factors of 70 are 1, 2, 5, 10. I missed 7. 10, 14, 35, and 70 itself. I could have also written 44 up here. So the greatest common factor that goes into both these numbers is the number 2. So the GCF of 44 and 70 is 2. Now you could do 4b. The next thing we're going to look at is the LCM, or lowest common multiple of a number. The lowest common multiple is the number that both numbers will go into evenly. So it'll be bigger or the same as the numbers. So if I'm to list the first 10 multiples of each number, multiples of 7 will be like 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. Multiples of 10 will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So the smallest number that each of these numbers will divide into evenly is 70. And so the LCM of 7 and 10 is 70. Now you can try 6, A and B, as well as number 7. It's tricky. You need to find the LCM, is the hint I'll give you. Good luck. Let me know if you need help, and I'll see you tomorrow for the next lesson.